Welcome back to the Grandstream video guide series. Today's video is about LLDP. We will explain how LLDP works and demonstrate how to configure it on the GWN switches. Link Layer Discovery Protocol, or LLDP, is an industry standard Layer 2 neighbor discovery protocol. Devices use LLDP to periodically advertise information about their capabilities to neighboring network devices. Switches rely on LLDP to collect information about their connected devices such as device name, its capability, port ID, and many other characteristics. This information is stored in a local management information base that can be queried by the network management system using SNMP to learn and build the network topology. Network devices transmit LLDP data units at fixed intervals on all LLDP-enabled interfaces. On GWN switches, the default interval is 30 seconds. The transmitted data unit includes multiple attributes which are referred to as TLVs. Each TLV contains a particular type of information about the device and the interface transmitting it. This is an example of an LLDP message that is sent by an IP phone, and it shows detailed information about the IP phone and the supported capabilities. The message contains the IP address, the MAC address, the device name, and the running firmware version. The advertised capabilities reveal it is an IP telephony device. In addition, the LLDP message carries several TLV types such as port description, serial number, asset ID, and media capabilities. LLDP Media Endpoint Discovery is an extension to LLDP, and it offers additional parameters such as VLAN assignment, Layer 2 priority, and Layer 3 quality of service. It can be used by a switch to convey the voice VLAN configuration to a media endpoint such as an IP phone. The media endpoint then uses the VLAN information contained in the LLDP message from the switch to configure itself. Most IP phones are built with two Ethernet ports. The LAN port connects to a switch, and the PC port is used by a computer to connect to the local area network through the IP phone. It is always a good practice to separate voice traffic from data traffic by assigning voice devices to a particular VLAN. This ensures that voice traffic gets a higher priority when quality of service is applied. To manage the VLAN assignment from the GWN switch, an LLDP network policy can be created and manually assigned to the desired ports where IP phones are connected. Now let's go to the web interface of a GWN switch to explain the available LLDP features and demonstrate how to implement VLAN assignment through LLDP. From the Admin panel menu, click on Maintenance and select LLDP. The Global Settings tab allows us to configure the LLDP global timers, such as the advertised intervals for LLDP and time to live multiplier. TTL multiplier specifies the amount of time an LLDP message is valid before it expired. For instance, if TTL multiplier is set to 4 and the TLV advertised interval is 30 seconds, the LLDP message is discarded after 120 seconds. By default, LLDP is globally enabled. If it is determined that it is not needed for normal operation in a network environment, it can be disabled globally by toggling the LLDP option. Port reinitializing delay is the time the port waits before transmitting LLDP messages when there is a change in the LLDP status. The transmit delay time sets the minimum time between transmitted LLDP messages. This ensures the switch does not transmit excessive LLDP messages in a short period of time. To configure LLDP on a particular port, we go to Port Settings and select the port you want to configure. By default, the switch ports are configured to send and process LLDP data units. LLDP can operate in one of the following modes, including disabled if you decide not to enable LLDP on a particular port. Next, choose the TLV attributes that the switch will advertise to neighboring devices through LLDP messages. For instance, you can uncheck the management address if you don't want to convey the management IP address of the switch. An LLDP network policy is a set of configuration parameters that can be applied to specific ports on a switch to instruct media endpoint devices to send traffic on specific VLAN with the defined priority and quality of service. To add a network policy, click on Add. The switch will automatically choose a policy ID number. To apply the network policy to an IP phone, choose Voice. Specify the VLAN that will be used for voice traffic and select whether to be tagged or untagged. In our example, we will select Tag It. Next, define the class of service and Layer 3 quality of service. We will choose the value 5 for class of service and set the diff-serve code point to 46. The selected values will ensure a higher priority for voice traffic. Then, apply the changes. Fast Report Count temporarily overrides the advertised interval when a switch detects a connected device that supports LLDP-MED. Using the value 3 means the switch will transmit an LLDP data unit every 3 seconds when it first detects a device with LLDP-MED support, and it does it for a limited time to allow the connected device to receive the network policy faster. We go to the LLDP-MED port settings tab to apply the network policy to the desired ports. Select the port and ensure LLDP-MED is enabled. Toggle the network policy TLV to select the network policy that will be applied to this interface. We will select the network policy that we just created. Inventory TLV allows the switch interface to include inventory details about itself in the LLDP message, such as the firmware version, serial number, model number, manufacturer name, and hardware version. Location Identification TLV provides location information to the media endpoint such as geographic coordinates, civic address, and emergency location identifier number for emergency calls. PoE TLV is enabled to convey the power management capabilities of the switch port such as power priority and the actual power granted to the media endpoint. Click OK to save the changes. There's one more thing to mention regarding VLAN assignment using LLDP. In the network policy that we just created, we chose Tag VLAN 20. For that to work, we must set the port to use Tag VLAN under VLAN configuration page. We are working with VLAN 20, so edit VLAN 20. Select the port and click on it to tag the port. Save the changes. Now if there's an IP phone connected to port 10, it should get assigned an IP address from VLAN 20. Device Info tab displays the local information advertised globally and on a particular port. To confirm and display the LLDP information and capabilities enabled on a specific interface, scroll down to Local Port Info and select the desired port. For example, port 10 shows the network policy that we just applied to this port, which includes the VLAN number and the quality of service setting. Neighbor Info page displays information that was received through LLDP messages from connected devices that are LLDP enabled. The information displayed includes the list of neighboring devices with their IP address, MAC address, device description, and survival time. Earlier, we configured port 10 with a network policy that will instruct the IP phone to use VLAN 20. In response to the network policy applied to this port, the IP phone is now sending traffic on VLAN 20. If there is a computer connected to the PC port on the phone, the data traffic is sent with the default VLAN, typically untagged with default priority. The Statistics tab displays LLDP statistical details for each port. The field for total packets transmitted displays the number of LLDP messages sent by the switch on each switch port. The column for received frames indicates if a switch port has received any LLDP messages from the connected device and the total number of these messages. This concludes today's video guide about LLDP. Stay tuned for more video guides about the GWN780x series.